Hey guys, welcome to Pungi Modularity demo. I'm going to show you differences in my prototype against upstream. So the good start would be check out this repository, which is available on Azure. Here it's called Pungi Modularity, and it has some example scripts and the checkout modularity into current dir script, which will check you out all the repositories that this demo depends on. Are these. So the difference in between upstream is that we do each individual step separately. So you can do depth solving separately from repo creation and composing all the bits once you have all repositories available, all Docker images built and ISOs created. So in this demo, I will just show you depth solving separately from linking and create repo, and then composing once we already have existing repositories, and then I will import it into PDC. So make sure to set your Python paths correctly. And we can do example gather core, which does all the depth solving for core module. You can see that I take some local repositories as source repository for all the depth solving. It will be Koji in production. And then it's R specific depth solving, right? Since every single arch can result into different result. And the target directory, which will contain all the repositories. Static manifest with depth solving, which is just a list of nevers you will see by yourself. And the input file looks like this. So we are using the Pungi inputs core YAML, which has just a list of packages that should appear in the repository or module if you would like to, plus their dependencies, of course. Yeah. Example, gather core. Takes a few seconds and results into 991 nevras. We are actually using DNF for depth solving and also for linking and everything, which is different from the upstream Pungi. So once you have the depth solving, we can actually see how something that I call RPM static manifest looks like. This list of nevras. I'm actually having some JSON metadata, which is just saying, okay, debug RPMs are available in this file's RPMs, in this file source RPMs here. And I'm actually storing hashes of configs. I should also store configs, hashes of repo data, but it's not yet done. So let me show you how RPMs looks like. It's just a list of nevras, same for debug and sources. So it doesn't change over time, and you know that if you are going to produce compose based on this static manifest, all of these will be available in the repositories. So let's do example create repo based on the static manifest that we already created. Basically takes the static manifest as input, and that should be pretty much it. Also target there where the repository is going to be created. We are actually creating 3 repositories, not just one for RPMs, the other for source RPMs, and third for debug RPMs. If you'll check how the example create repo looks like, it's just target there, source repositories, which is saying, hey, you would like to link RPMs from these repositories. Again, it would be Koji, but we don't have access to mount Koji from Fedora, and do it for this architecture, which is a requirement for DNF. I would like to get rid of this option in the future. An extra file which will end up in repo data, which is FM metadata module MD file. So we have source. Now we can actually generate shells, which is another module. Gather shells, which already depends on core. And once we did everything separately, it actually requires some sort of order to create it. Once you have all modules, generated, you can actually do incremental creations based on the existing bits, since you can't do something that depends on core without having core created, right? So example getter shells, that will just do dep solving for shells minus packages that are already in core. So it's 22 packages here. Then debug packages 21 source of packages. And we can just do the same, create repo for shells. In real life, this would be triggered by messaging. And now when we have repositories for shells and core, we can do compose. It's really just saying, hey, this is compose for this release, and it should be defined out of these variants, which are defined in the same variants file as we are using for upstream Pungi. This is just saying, hey, this is going to be variant of this version, and it's going to have variants core and shells. Both are module, which is different. We don't have that upstream yet. And the shells is this dependency. And once you actually run the Pungi compose, it will take the latest trees. In my demo, it's the latest. However, I would like to gather it from PDC in the next sprint. Run Pungi compose, and it just generated the metadata for compose from existing trees. The question is whether we would like to relink all the files that appear in the existing repositories or just stream repo data and point it to trees which already exist. So I am doing just the metadata right now. And let's actually import it into PDC. So I have some trees already imported, and the new tree is called 19.2, which is missing. You can see it's not there. PDC. And this one is 19.2. Done. And you can actually see all the RPMs for core. All the RPMs for shells. And also some related images, but we don't have really any. And that's all. So see you next time, guys.